Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at dataengineeringpodcast.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your data pipelines or trying out the tools you hear about on the show. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. You can help support the show by checking out the Patreon page, which is linked from the site. To help other people find the show, you can leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. I've got a couple of announcements before we start the show. There's still time to register for the O'Reilly Strata Conference in San Jose, California, happening from March 5th to the 8th. Use the link dataengineeringpodcast.com/strata-san-jose to register and save 20% off your tickets. The O'Reilly AI Conference is also coming up, happening April 29th to the 30th in New York. It will give you a solid understanding of the latest breakthroughs and best practices in AI for business. Go to dataengineeringpodcast.com/AICon-new-york to register and save 20% off the tickets. Also, if you work with data or want to learn more about how the projects you have heard about on the show get used in the real world, then join me at the Open Data Science Conference happening in Boston from May 1st through the 4th. It has become one of the largest events for data scientists, data engineers, and data-driven businesses to get together and learn how to be more effective. To save 60% off your tickets, go to dataengineeringpodcast.com/ODSC-East-2018 and register. Your host is Tobias Macey, and today I'm interviewing Ajay Kulkarni and Mike Freedman about Timescale DB, a scalable time series database built on top of PostGreSQL. So if you guys could start by introducing yourselves.
Hi, I'm Ajay. I'm the CEO, and this is our CTO, Mike.
Hi, everybody.
And Mike doubles as a professor of computer science at Princeton, and we're the co-founders of Timescale. Mike and I actually have a fun history. We actually go back 20 years, back to the first week of college at MIT, where we were roommates. Since then, I actually stayed, I went into industry, went back to business school at MIT, and then started a company around communication analysis. That was later acquired by GroupMe, which was then acquired by Skype, which was then acquired by Microsoft. Then all three of those acquisitions happened in 6 months. And in parallel, Mike actually went into academia, earned his PhD from NYU and Stanford. And while at Stanford, was part of the team that developed software-defined networking. While at Stanford, he also started a company called Illumix around IP geolocation that was then acquired by Quova/Newstar. And then ended up at Princeton, where he's teaching computer science. And as it was around the time where I was, halfway into my golden handcuffs at Microsoft, and Mike had gotten tenure at Princeton, that we decided to team up again to take on this new challenge. That new challenge was actually around helping developers and companies manage the increasing amount of machine data and time series data that their businesses were generating, and that's why we started Timescale.
And if you could go a bit deeper into how you each got involved in the area of data management.
Yeah, it's one of those kind of fun startup history stories. We started off not building a database, but actually building an IoT platform. What we saw was that there was this rise in machines. In fact, we saw that the computing industry moves in waves, right? It moved from mainframes to desktops and laptops and then smartphones. And with each wave, the computers become smaller, but also more powerful and more ubiquitous. And you might remember Microsoft's original slogan in the 80s was, computer on every desk. And now with smartphones, you could argue a computer in every pocket. What we've noticed now is that we're entering a new wave with a computer in everything, right? And these things include our vehicles, our manufacturing lines, our farms, power plants, our homes, like with the Alexas of the world, and even in our bodies. And so, what Mike and I realized was that as human beings, we were now living with machines, and as businesses, we were swimming in machine data. And we actually started off, with that hypothesis, but with actually a very different product. We started off with an IoT platform, and the IoT platform, helped people who were making these devices analyze their data and monitor their devices. And what ended up happening is we were collecting all kinds of time series data, all kinds of sensor data, and we need a place to store that sensor data. And so we use a few off-the-shelf time series databases. And actually, after several months, we realized that we were quite unhappy with the state of the time series database world. We felt like we had, essentially a choice between reliability and ease of use, but lack of scalability, i.e. relational databases, or we had no SQL options, which were scalable, were actually hard to use, not that reliable, not that performant for complex queries, and in fact siloed our data into two different databases. So we actually had this insight. It's like, we feel like we could build a better time series database on top of Postgres. And so then, being a group of computer science academics and PhDs, we just built that database, but we initially just built it for the IoT platform. But then a funny thing happened is that as we were selling the IoT platform, we got some companies to sign on, but we also had a lot of companies that said, and especially larger companies who said, look, we can't use your IoT platform because we're building our own IoT platform, but tell us more about this database you built, because it sounds like it's something that we could use as well. And that's when we kind of realized that the solution to the IoT problem was, not another platform, but a better database. And then as soon as we became a time series database, we realized that the time series data problem was even much bigger than IoT. It was, in fact, problems in other industries as well, like finance and advertising and eventing and logistics and so forth. And so that's essentially how we essentially got into the database world. That's the whole story.
And as far as time series data, what is it about the sort of nature of how it comes in or the ways that it gets stored or used that makes it such a difficult problem to solve? And also, as you mentioned, there's already sort of a vast array of time series databases available. So I'm wondering how you view your position in the overall market and what makes Timescale stand out from the other options.
Let me start by the first part of your question, which was what makes time series data different? And you frame this by saying, what makes it more challenging? And one of the basic answers is the volumes of this is, so much larger than what you have historically seen in many, OLTP or transactional databases. If you think of a large bank, let's say like Bank of America, you might have something like 50 million customers. So conceptually, you might think that, you have 50 million accounts. That's how large your primary database is. You're doing operations to modify balances and so forth. But if you think about time series data, you have this vast array of streams of sensor data and event coming in, and they keep building and building. And we see that across many areas of new types of machines, of connected cars, of industrial machines, putting out more and more data. Now, one of the interesting things about it is that the nature of those workloads are different. So if I go back to my example of a traditional transactional database, what you might actually be doing is commonly performing what are effectively random updates to the database. I have two records, I do a transaction, I modify both those records in place. And that's what a lot of the high performance OLTP market has focused on. And so when you talk about scaling that, you need to think about how do you scale that workload. But when we talk about time series workloads, the workloads look different. In fact, most of the operations are actually inserts, and they're mostly to the latest time intervals. It's this new wave of data coming on. And when you do queries, you might actually be scanning them in different ways, but largely with certain time regions or about certain types of devices or stock tickers that are kind of first-class citizens in your data. And so in some sense, when you think about scaling relational databases, that has been a question that people have been working on for 30 years. And what we actually did was we're trying to solve a different problem, because we're trying to solve this problem, but for those time series workloads that are append heavy, insert heavy to the latest time interval, as opposed to the random updates that are common to transactional workloads. And that has allowed us to rethink how we want to kind of build up from a relational database and how we want to design the whole architecture around this workload.
And you have a very detailed blog post on your site that explains a bit about the design decisions for how Timescale is implemented. And you mentioned there the fact that the data is largely append only and immutable. And one of the challenges for time series in particular is the fact that you may receive events out of order, or you may have sensors that are infrequently connected, such as mobile devices or low power sensors. And so you need to be able to handle those events coming in out of sequence. So I'm wondering if there are any particular challenges that are faced because of those requirements and how you handle that internally in the database.
So all of those cases actually work out of the box with Timescale. And I should say that when I say they're append mostly or insert heavy. What we say is our performance, the way we get our performance benefits is we rely on those assumptions. But we don't require that for a correctness perspective. You could update our data, you could delete data in Timescale like you would with a traditional database. And when you talk about out of order, we kind of don't rely on the fact that all data comes exactly in order. That is, of course, sensors are going to be perhaps late, and not all clocks are going to be synchronized, and the timestamps are going to be a little off. But what kind of our performance assumptions are driven by is that they, for example, all come within roughly the same interval. So we kind of do this very kind of automated and native time and multidimensional partitioning, where maybe, let's say, the last hour of your data naturally stays in memory, based on just the way we underlying had architected the database. And so if any of your data comes within the last hour, it is very efficient, all stays in memory, and really drives forward that high performance that we get. Even if the data is delayed by more than several hours, it still works correctly. It just occasionally has to do a couple lookups to disk to handle that. Now, the other thing you mentioned is the out-of-order data, is that a common use case in time series databases is the ability to want to do continuous aggregations or roll-ups, where you might continuously be calculating averages or other metrics over time, so that you continuously compute, let's say, your 1 minute average and your hour-long average in order to, again, make queries later faster. And we kind of have very nice native support for this, but it also works with out-of-order data, so that if data comes into time periods that have already been pre-computed, again, the database makes it very trivial and transparent to recompute those calculations so that you continuously get the correct answer and not have multiple inaccurate records in your database like some other options on the market.
And I'm wondering if you can talk a bit more about how the database itself is implemented, particularly given its nature as an extension to PostgreSQL. And along with that, if you can talk about the impacts that the 10.x release has had on the implementation details of your project.
Yeah, so as you alluded to, Timescale is actually implemented as an extension on top of Postgres. And this was a very careful decision that we made when setting out to build it. In doing so, effectively what we do is we give the illusion to users and to operators that we look like a Postgres database. In that, even though if I have this, we call them a hypertable, it looks like a standard Postgres table. You could have a hypertable of 1 million rows. You could have a hypertable of 500 billion rows, and we've had users have a single hypertable at 500 billion rows. But under the covers, of course, we're doing a lot. But what that gives you on top of Postgres is it inherits the entire ecosystem. So if you're a tool that speaks to Postgres, you could speak to Timescale. So if you use an ORM, like Ruby or Java Hibernate, if you use a visualization platform like Grafana or Tableau, if you use admin tools, if you use a queuing system or a pipeline system like Kafka, all those things will just work out of the box with Timescale. And that has been a very powerful thing, because what we often find is people say, well, I love Postgres. I started building this on Postgres, but then I hit this scalability limitation. And now, do I have to throw the baby out with the bathwater? Do I need to go to a completely different system? Do I have to hack together something that kind of sort of works and is hard to use? And with Timescale, you install our extension, and you could basically keep scaling on and even get much higher performance than you would. Insert time, 20x the performance that you would with native Postgres. And so both from the user's perspective, it inherits basically probably the largest ecosystem of any time series database out there, because it inherits the entire ecosystem of Postgres. And then also is that inherits the 20 years of reliability that Postgres has had. Ajay wrote this interesting launch post, I think it was called "When Boring is Awesome," in that you want your database to just work. You don't want your database to work about 3 a.m. because you threw some random seg fault and you lost data. In that we saw that really as a database, this is an operational database that powers mission critical applications. It's a core part of infrastructure, and it takes 5, sometimes 5, but often 10 years to reach the reliability that you want from that type of infrastructure. But we could provide that today because we figure out how to make Postgres this amazing product work now for time series data. And your second question was 10.0, and there's a lot of great things with 10.0. It gives a lot of parallelization support. It obviously has some support for partitioning, but so far our users have had a great experience. We support Timescale running on 10.0 across all different platforms, and users have been able to take advantage of Timescale combined with Postgres 10, take advantage of a lot of some of the parallelization support and other type of new features that Postgres 10 put out. And it has been a great product for us.
Yeah, just to add to that, we're huge fans of the Postgres community. We love the fact that 10 came out last year, 11 will come out this year, and we want to see that growth continue because I think it's just great for developers. I think with 10 and even with 11, there are still quite a few limitations when it comes to time series data, and I think some of them over time may improve, but some of them over time may not make sense to be in mainline. And so I think, with all the improvement, Timescale can still add a lot of value on top if you're using Postgres for time series data. But that said, we love all this development, and we're big fans and supporters of the Postgres community.
And given the fact that it is an extension to Postgres, is it possible to deploy it on top of managed platforms such as Amazon RDS or Google Cloud SQL or the Azure database offerings?
It's not yet, and if you look at, I think our GitHub issues, I think that's our number one GitHub issue by far is people requesting support for Timescale on some of the managed offerings. And we hear from customers that they've requested this from Amazon and Google and Microsoft. So we may see something sometime in the near future, but it's currently not available.
And the reason it's not available is not a technical limitation of Timescale interacting with these products. It's more a question of getting launched on these different platforms.
And so for somebody who does want to start using Timescale, what would be involved in getting it deployed and maintained? And what are some of the resource allocations that they should be considering for deploying the database on top of?
Yeah, so there, I'll answer that in a few ways. Number one, we support a variety of installation and deployment options. And so in terms of installation options, our most common is either via our Docker, via Docker or via some of our kind of Linux-based package managers like apt-get or yum or RPM. We also support for Macs, which a lot of people use via Brew for local testing. But also in terms of deployment, because we're a database and we're a Postgres extension, we essentially support a variety of deployment models. We have anything from the public clouds to even private clouds to servers on premise to gateways at the edge or even the edge device. We've already tested Timescale on a Raspberry Pi, and I'm not sure if someone today is actually using that, but we do have usage on Linux-based gateways at the edge. So essentially, you can either scale up or scale down with Timescale. In terms of resources that are available, generally most people that we work with today, have their own, resources in-house for managing databases. Larger companies have DBA teams, some smaller companies have their own DevOps teams, but also, we do provide enterprise support for companies who need higher levels of support or an SLA. So that's an option as well. But to be perfectly honest, because we're packaged as Postgres, most people have pleasantly found that a lot of the tools that they already use, whether for backups or replication with Postgres, just work out of the box with Timescale.
And one of the main selling points of Timescale is the fact that you can scale all the way from small devices to large installations. So I'm wondering if you can describe a bit about what the axes for scaling happen to be and where are the points where that scalability starts to break down.
So the axes for scaling are typically, like Ajay said, we've had people at least test us on Raspberry Pis. It's not, typically the most performant platform due to the hardware, but certainly works on a gateway. And sometimes, in thinking about time series data, and a time series database, there's really two axes that we think about. One is that of scale and performance, but the other one are things like time-oriented analytical capabilities and time-oriented data management. And so I say that because, for example, things like doing continuous aggregation and data retention, such that you might keep raw data for a week and then aggregated data for a month. The reason you might adopt Timescale on these low-power devices is because it makes time series data management easier and some of the analytical features we had easier, as opposed to the fact that, on a Raspberry Pi, you're not doing 100,000 inserts a second. And so there's really different decisions on why you deploy timescale in these two axes. And one of them is that we also, because we actually allow you to, along with your time series data, store your relational data, what we found, for example, on the edge is now somebody could have a single database, basically a Postgres database running timescale that they could use for all of their data. And it basically allows them to simplify their stack on the edge. Now in the cloud, of course, people have, or in on-premise, people have scaled up. We support two types of clustering today. That is, we allow you to do kind of Postgres streaming replication with multiple read-only replicas, so you could scale the number of actually servers you have answering queries. And we also, very interestingly, allow you to elastically scale your storage, even associated with kind of the master and replicas of the timescale cluster. And that is, we kind of have this unique thing that in one hypertable, unlike a traditional Postgres database and most relational databases, in one hypertable, which again to the user looks like a single table, we allow you to actually elastically add disks. So if you're starting at 1 terabyte today and you need more space, you could add another 5 terabytes and another 10 terabytes, and you could keep adding disks. And then we will again do the time series nature workloads. We will continue to load balance all your new inserts over these new disks. So we've had people take this to the realm of, I think, 50 or 100 terabytes in more, kind of private cloud environments.
And Tobias, let me also answer that same question a different way, because I suspect the next question you might ask is, at what point does the scalability break down? And typically we measure scalability in 3 ways. One is insert performance, the other is query latency, and the third is kind of essentially just data volume. In terms of insert performance, today we support hundreds of thousands of inserts a second, and of course those are row inserts per second, and if a row has 10 metrics, that works out to millions of metrics per second. So I would say number one today, if you need an insert performance, let's say in the tens of millions of inserts per second, then we currently don't support that, but obviously, it's one area that we are working on, so that will change in a year. The second thing I want to point out is query latency. Query latency, we actually have a great story there because we're built on top of Postgres and a relational database. You can build hypertables with as many secondary indexes as you want, which allow for really complex queries, really efficient complex queries. Also, because we look like Postgres, we support Postgres streaming replication, which allows you to have one kind of master, but have several read replicas, and those read replicas allow users to essentially increase their query throughput by round robining queries. That said, if you think most of your queries will touch all of your data, i.e., you can't leverage indexes, then that is where timescale may not be the best option. You may want something that's more MapReduce in nature, as an example. But it's typically what we say. The third thing is data volumes and disk storage. And as Mike pointed out, because of our hypertable framework, it allows us to build this logical table that effectively spans across multiple disks. And that's allowed our users, on a single machine, 10, 20, 30 disks that have allowed them to grow their data volume to 50, 60, almost 100 terabytes just on a single machine. And so that's where we are today. One thing we're working on is being able to scale it out across multiple machines, which would allow us, in a year to get, to a petabyte of data volume. But that said, if today you see yourself having petabytes of data, or you're even beyond that, we would not recommend timescale, and instead recommend something that's more file system based, like an HDFS based system.
And a couple of things coming out of that is you mentioned the ability to use streaming replication and then do query balancing for read replicas. I'm wondering if Timescale adds any capabilities for proxying those queries to the read replicas by itself, or if you would be relying on one of the existing tools in the ecosystem, such as pgpool2, for handling the balancing of whether the queries go to the slaves or the master for read or write.
Yeah, Today, we recommend actually using one of the tools in the ecosystem. I mean, in some sense, that's one of the advantages we have as building on top of Postgres is that there is such this rich ecosystem, and often different deployments and companies and users want to use different things, either things like are custom built for Postgres, or things that with all these new container management systems like Kubernetes or Docker Swarm, there are other ways that you can get this similar type of functionality. So there are currently just a whole variety of different ways that people could do this. And, we often make recommendations. People ask us on some of our support channels, but there's a lot of easy support there. As Ajay was talking about, one thing that we're working on is kind of more native scale out, where you could have many primaries that will increase the total capacity. And there we're going to have kind of better or more built-in support to make this transparent than using these third-party extensions in Postgres.
And speaking of those third-party extensions for horizontal scale-out, I was wondering if you or anyone you're aware of has explored running Timescale in conjunction with Citus for being able to do that horizontal partitioning to scale across multiple instances, or if the nature of the hypertable makes it sort of impractical to use those combination of technologies.
Yeah, it's a funny question. I feel like it's a question that someone always asks when Timescale comes up or Citus comes up. I think if you look at the recent Hacker News articles about either Citus or Timescale, there's always a question about the other option, if they're compatible. The answer is we don't know. We have not tried it. We don't know if anyone else has tried it. It's possible that they work together. Possible that they don't. One thing we found is that typically Citus and Timescale are solving. They're both scaling Postgres, but they're scaling it for very different workloads. And in particular, we're very time series oriented, very time series specific, which we believe is a large enough and complicated enough on its own that it requires a specialized database. What we think the world will look like is if you end up using both, you might end up using both on different machines, and maybe using something like a foreign data wrapper to query across the two. But in short, we really haven't tested it.
In some sense, part of our goal with Timescale is to really make the data management, use, and analysis of time series data easy, performant and easy. And so this whole idea of a logical view, a hypertable, we basically want to make it to look like you're interacting with the data. One table, you don't care where it is, you don't care how big it is, and so forth. And so really to give such a great user experience and such a performance and a reliable, you have to really think about what this database, what this system looks end to end. You have to think about how you get performance, how you get correctness semantics. And so while you can kind of cobble together different solutions, in the end we think the best solution is going to be something that really tries to tackle the problem holistically, focuses on one problem well, and just really, does that, really executes on that. And that's kind of why our vision is in trying to, as we build that to scale out, how do we build it knowing what we need for the time series database problem, as opposed to thinking, how do we cobble together different tools to get something that kind of sort of works.
And to that point, I like to stress that, our scale is in our name. and I think we built our initial kind of brand around scaling Postgres for these workloads. But I think the other half of that, which often goes unnoticed, but I think is equally important, is ease of use. And one thing we've really strove for is as you are writing time series and querying time series data, you shouldn't have to worry about anything. You shouldn't have to worry about how your data is stored, how your data is partitioned. And we effectively handle all that behind the scenes. If you're writing data to Timescale, and your volume increases, we will automatically, write the new data to new chunks, and we'll create new chunks as necessary. In fact, we've had some customers who were writing 500,000 inserts a second, and at that volume, they're creating a new partition every 2 to 3 minutes. And that's actually not even feasible if you're trying to do it manually. But with Timescale handling behind the scenes, they'd have to worry about do we need to create a new chunk? Oh, is it a new child? Oh, how do I join across the partition boundary? That's all behind the scenes. And there's actually a lot of work we've done in creating this hypertable abstraction. The hypertable abstraction layer essentially presents this illusion of a logical table across all time and space, across all your data, even though behind the scenes the database is storing the data across multiple partitions and creating new partitions as necessary. But what we've essentially done is essentially like enforce this contract that says this hypertable will look exactly like a table to you. So if you're inserting data, you insert to the hypertable. If you're querying data, you query the hypertable. If you're creating constraints, you create constraints on the hypertable, indexes on the hypertable. And Timescale will transparently behind the scenes create new chunks as necessary, query the appropriate chunks efficiently to retrieve your data, and then propagate constraints and indexes to each of the underlying chunks. But the key thing is, as a user, you don't have to worry about it.
And on the subject of indexes, that also touches both the ease of use and the scalability aspects, because as anybody who has used a relational database for long enough and occasionally in the wrong manner, you know that adding too many indexes or indexes of the wrong sort can completely destroy your query performance. So I'm wondering if you, in the process of building Timescale, ended up needing to either create or modify new index types, or whether you automatically add some form of indexing to the hypertables to make it easier and more performant to query that data?
Somewhat two parts of your questions, which is, one of them is why, for example, given that Timescale has built on top of Postgres, how do we claim that we get, or why do we get 20 times the insert performance? And one of the reasons is if you have index data, effectively what happens is when you insert a new row, what you're going to try to do then is, of course, update all the indexes. So, for example, if you actually have some index on, let's say, time or on some other ID, as you write the latest data, you're now going to try to update that index to be properly in place, properly maintain the right sort order for the index so you can do efficient queries. And what that means is as you're, when you have 1 million rows in your database, maybe everything's fine, everything's in memory, things are fast. When you have 1 billion rows or 100 billion rows, you're going to start swapping a lot. And that's when your performance is really going to plunge. So one of the ways that we kind of architecturally make that much faster is that our indexes are all local to every partition, to every little chunk. So when Ajay was saying that, these chunks were dynamically created every 3 minutes, the indexes are only within that 3 minutes worth of data, that 10 or 20 million rows of data in that couple minutes. It's not across, 500 billion rows in your entire database. And so what that means is you, again, kind of naturally take advantage of the locality of the data to keep the index that is actively being changed in memory and fast. And then the stuff that's not being modified sits on disk, doesn't get modified. Maybe asynchronously you could reindex it and make it more efficient or cluster that chunk. And it's kind of the access pattern to all these chunks, which has allowed us to kind of overcome some of the performance hits that you see when trying to take a traditional relational database and just make it much larger. So we haven't really yet gone down the path of trying to build custom indexes and then different types. In fact, Postgres is great in supporting a whole host of things, and B-trees and hash indexes and Brin and Gin and Gist and a whole set of indexes. We support them all, but we make them small and localized to data that is often accessed both from an insert and query perspective together.
And given the complexity of the problem space that you're trying to solve for, I'm wondering if you can talk a bit about what the most challenging aspects of building Timescale have been, both from the technical and the marketing or promotional aspects.
Let me start with the marketing side, then I'll let Mike answer the technical aspect. I think with marketing, I actually point to a couple things. Number one, we're pretty new. We're a pretty new database, right? We launched last April, but in those 9-10 months, we've actually quite a bit of growth. We recently just passed 100,000 downloads, and we're being deployed by real customers. Real use cases in manufacturing, and utilities, and in telecoms and even finance. And I think one challenge for us, which I suspect is a good problem to have, is because we're so new, a lot of people don't realize how robust and advanced the product already is. And I think last week we announced that for example, we have companies like STE Energy in Italy, which is a renewable energies utility. They recently replaced Redis with Timescale to back their operational dashboards that they use to monitor 47 power plants in Italy and Albania and Colombia, Peru, and a variety of other countries. And I think that caught a few people off guard. They said, wow, like how is a company like, how is an Italian utility, which you wouldn't think of as, as the earliest tech adopter, how are they betting on a less than year old database? Well, it's because Timescale, because of the approach we've taken, of course, some of the engineering decisions we've made as well, is already quite robust. And despite being less than a year old, we were deployed in production. We've been deployed in production for months already. So I think that's number one is to essentially say, hey, I know you're used to most databases taking years to get production ready, but we're not most databases. We've been production ready since like month 3. And so, so that's number one.
Part of that is because we're not trying to build from scratch, and we stand on the shoulder of giants. We stand on the shoulder of 20 years of Postgres development, which has put correctness and reliability and dependability at its core.
I think the second challenge in terms of marketing and outreach has been, there's just a lot of noise in the database market right now. And we found that a lot of people are somewhat fast and loose with their marketing claims. And we try not to do that. But as a result, we find ourselves, having to work harder to actually show how we're different than other options. One example of that is full SQL. A lot of databases, including Timeseries databases, claim to be full SQL. But if you kind of scratch below the surface, there's like an asterisk. They'll say, oh, it's full SQL, but we don't support joins, right? Or full SQL, but we don't support window functions. And in our minds, joins are a pretty fundamental part of SQL. And in fact, even for a lot of our users, window functions are pretty critical as well.
Or you could only order by time.
Right. It's we support full SQL, but only ordering by time. We don't order by any other key. And for us, it's like it's tough because they've created a lot of misinformation that we essentially have to cut through and say, okay, I know they claim they're full SQL, but they're actually not full SQL, and we actually support all these other things as well. We in fact support everything that Postgres supports, literally everything, which I think most people would agree is full SQL. And we say, look, if you don't need joins, if you don't need window functions, if you're okay ordering by time but nothing else, then maybe that's good enough. But what we found is that most people need the full spectrum of SQL, or at least, for future-proofing reasons. They want to be reassured that if in the future they need to do joins, if in the future they need to do, use geospatial data with something like PostGIS, they'll be able to do that with Timescale. Be able to do that with their database, which, they can do with Timescale. I don't know, Mike, you want to talk some of the technical challenges we've had?
I think the technical challenge goes back to what we view as our mission and what we expect people to rely on us for. In that, building a database, you're really a core part of a company's infrastructure, and they rely on you. So if you think about the web world where, Facebook was able to get great products out because you move fast and break things, that might work for a social media platform. And, they've done massively impressive engineering. But that is not the goal of a database. And so I think our technical challenge there is perhaps not surprising in the sense that, we always need to keep an eye on that the features that we look to provide to our users because they're asking for them are also countered, of course, that we need to be, do this with safety, security, and insurance foremost at our minds.
And again, going back to the fact that there are so many other time series databases on the market, I'm wondering if there are any that you would call out as being ones that you personally view as your closest competitors, or ones that people may want to move off of in favor of Timescale.
We don't really think about other databases competitors, but we just think of them as other options that developers have with time series data. And I think you have a variety of options, and I can kind of explain how we compare against them. One option is that, if you have time series data, but you don't have a lot of it, let's say you're collecting economic forecasts on a monthly basis, then, you should just store that in a relational database. I'm not really sure you need a time series database. On the flip side, if you're storing, lots of time series data, but your queries are fairly straightforward, maybe you're doing, lookups, or you're doing, single column rollups around the time dimension, and this data is not mission critical, then we would essentially point you to, some of the more NoSQL time series databases that perform well on that. But broadly speaking, in the world of time series databases, what we're finding is that until Timescale launched, every time series database, because the number one problem was scale, was effectively a NoSQL database. They essentially gave up the relational model for something that was more optimized for inserting data, but then essentially gave up a lot of the query power, and a lot of the complexity, and in some cases reliability as well. And so the way we like to kind of describe Timescale versus the entire time series database market is that we're the only time series database that's essentially built on a relational database, which means a few things. Number one, we support full SQL. And number two, we support all the good stuff that you get with a relational database, including joins and secondary indexes. And number three, because we're built on top of Postgres, we're actually quite reliable. And what we found is that despite being a few months old, we've had users come to us from older time series databases because they found that we're just more reliable, and we can't take the credit for that. It's really we can't take all the credit for that. A lot of that comes from the Postgres community. And number four is, because we look like Postgres, we essentially inherit the entire Postgres ecosystem. So if you want to use, Tableau or Grafana, or if you want to use any of the Postgres backup utility tools, or even if you have a question of, how do I do this in Timescale? We essentially have the broadest ecosystem and probably the most documentation of any time series database, despite the fact we're relatively the new kid on the.
And to follow up with one thing that Ajay said, at the beginning of this conversation, he talked about how we initially had built an IoT platform and we had tried using one of the existing NoSQL databases. And of course, what we did was we had all this metadata as well. We were collecting data about devices, so we had a separate, in fact, Postgres database that stored metadata about the devices and stuff they were. And what we ended up doing, like many probably startups that had this scenario of their time series data siloed in a time series database and the relational data, metadata siloed in a relational database, is that we punted this to the application layer. And we actually had to write in our microservices code that joined across these two databases. In every REST API call, when you do something, you would have to talk to these two databases. And sometimes the databases were not consistent because, somebody had written data to your time series database about a device that had not yet been registered. And then you had to resolve that and deal with all that complexity. And when we were talking to other companies as well, we found this as well, in that the data scientist wanted to do some analysis, but currently he had access or she had access to the time series database. But in order for them to merge across this database meant that they had to talk to engineering and somehow get engineering to modify the applications to support their new type of analysis. And that always kind of let people back. And so we found that, and when Jay was talking about, if all you want to do is simple roll-ups in a NoSQL database, we found that that might be useful. For example, if you want to do a simple dashboard where you just want to show the latest data about a particular thing across time. But once you start seeing, there's a problem here, let me figure out, why is there a problem here? I then need to go to my metadata and need to figure out what are the conditions about this device or about this environment that cause this. Then again, you can't get this directly from the system. You have to build more complex in the application. But because we support this whole thing, because it just looks like SQL, you could do both the performant dashboarding and analytical queries and also the ad hoc analysis. And that's also where we saw ourselves different from a lot of the products that were just looking to, plot trend lines.
Related to that in terms of plotting trend lines and also going back to your roots as a project for being able to capture machine data, one of the use cases that you call out on your website is to be used for systems metrics and monitoring in a server environment, which is particularly relevant to me because my primary role is as a DevOps or sysadmin. So I'm wondering how Timescale fits into that overall ecosystem and whether it can be used along with existing tools such as Graphite or Prometheus, or if it would largely replace them for being able to store your system metrics. And I know you already mentioned that you have direct integration with Grafana, which is becoming one of the popular front ends for that use case.
Yeah, we actually have direct integrations with both Grafana and Prometheus. The Grafana connector was actually developed initially as a Postgres connector, but the Prometheus connector is something we built. In fact, we wrote a Postgres extension that we later open source called PG Prometheus that essentially allows anyone to store, it actually creates a Prometheus data type within Postgres and allows anyone to store Prometheus data directly in Postgres. And then obviously with Timescale, you can then scale the workload. But at a high level, metrics is obviously a huge use case for time series data. And for us, we're not trying to replace any of these solutions. We're essentially a complement. And if you want a complement to Prometheus or Graphite that can store your metrics data in a way that's easily queryable using SQL or even using other tools, Timescale is a great resource for that. And as you already identified, we plug right into Grafana, so you can use this right away. And in fact, a lot of people will often ask us, do you support this metrics format or this metrics format? And one thing we found is typically the answer is yes, because typically someone has written a connector or a translator from a metrics format to Postgres, and again, anything that speaks to Postgres will speak to Timescale. And so that's kind of how we see ourselves fitting into that ecosystem.
And one thing I just realized that we forgot to touch on specifically is for somebody who wants to use Timescale in their existing Postgres database, is there a specific syntax that they need to add to their create table statements in order to enable the hypertable attributes for that given table?
Yeah. In fact, it's quite easy. It's quite easy to install Timescale in your existing Postgres instance. The first command, obviously, because we're an extension, is create extension TimescaleDB. And the next thing is, as you identified, is when you're creating a table, first you define the table using the standard create table statement. You define the schema. But right after that, you have to call our function called create hypertable. And create a hypertable takes a number of parameters that we talk about on our website for best use. But essentially, you just have to tell Timescale that, hey, I want you to treat this table as a hypertable, and then we do all the, for lack of a better word, the magic behind the scenes. But after that point, you write to the hypertable, you query the hypertable, you create indexes and constraints and triggers, just as if it was a normal. And so, after that one command, create a hypertable, you don't even have to change your code if you're migrating for Postgres. It essentially will just work exactly the same.
And does that function work properly against an existing table, or would you want to create a brand new table and then migrate existing time series data to that if you already have it stored in the database?
Yeah, currently it actually only works against an empty table. So you need to create a new table, call that create hypertable command on it, and then migrate your data. In the future, we'll consider possibly converting existing tables, but this thing is relatively easy. You can do it in the command, insert into new table, select from old table, or you could also, we've written and open sourced on our GitHub is a parallel copy command. Copy, although fast, is actually single threaded, and so with our parallel copy, we've had people do. I think one party almost reached 1 million rows per second at an insert rate, and so you could really load up this hypertable quite quickly.
And what are some of the most interesting or unexpected uses of Timescale that you have seen?
It's it's quite interesting. Our roots, the roots for Timescale was in machine data because we came out of an IoT platform company, and so we initially thought the main usage of Timescale would be IoT, right? Would be maybe old line industrial IoT like manufacturing machinery or utilities, or maybe even some new line like the smart home or any of these things that you see on Kickstarter. And then we thought, oh, okay, of course we're a time series database, so maybe we'll see some workloads that you typically see with time series databases like metrics and maybe finance. And what we found is that we've actually seen a lot more uses than just those areas. Early on we saw someone migrate to Timescale from Hadoop. Now this wasn't a petabyte size Hadoop cluster. It was something in the tens of terabytes. But even then, they moved that to a single Timescale node, and that caught us off guard because then we're like, wait, are we a data warehouse, right? and then we saw some other users who are deploying us in ways that other ways that we didn't expect. For example, with geospatial data. And when we started, we'd heard of PostGIS, but we hadn't really thought about geospatial temporal data. But it turns out Timescale and PostGIS are quite compatible. So if you're tracking an asset over time, you have both geospatial data and time series data, and we've seen a lot of usage with Timescale in that area. And effectively, looking back, I think what we saw in that first year is that time series data used to be this niche, right? It used to be this niche initially within the financial community, and that's where databases like KDB came out of. And then later, essentially, it became this niche within the DevOps community and metrics, which is where arguably every other time series data has come from. What we believe we're seeing today is that time series data is emerging in more and more places. Part of this obviously is IoT, but part of this is also, something we call the evolution of data resolution, which essentially it just says that it just means that as storage gets cheaper and data processing tools become more powerful, you're just naturally going to store data in higher and higher resolutions. And so in the past, you may have stored the latest balances of people's bank accounts. Today you'll store the transactions that essentially affect that final bank account balance. And in the future, you're going to store every possible interaction with the consumer, with the user, that essentially helps predict future behavior. And the further along that spectrum you go, the more and more time series data you're capturing. And as a result, time series data is evolving from something that used to be this niche into something that essentially all data is evolving into. and we strongly believe that over time, more and more data will evolve into time series data. And I think that's one reason why today you see, if you look at the DB engine stats, it's one reason why you see that time series databases have been the fastest growing category of database for the past 24 months. And I think Timescale, as the only time series database that supports relational database-like workloads, but for time series scale, I think we're really well positioned to help developers, with those sorts of problems.
And moving now to the business aspects of Timescale, I'm wondering first whether you had always intended for the code base to be released as open source, or what your reasoning was behind that decision, and also what the business model is for the company to be able to support the future growth and health of both the business and the project.
So Timescale, again, was initially just a product we built for ourselves. It was a database that we needed, so we built it, and then we found that other people needed it. So the question is, if other people need the database, how do we offer to them? In our minds, there wasn't a question. It was just, if we want to use a database today, we would only use an open source database. And so out of the gate, we're like, okay, if we want to offer this, it needs to be open source. And then we essentially spent 6 months open sourcing it. And then effectively we became an open source database company. And so then the question is, as an open source database company, how does one support oneself such that you can continue to build the database and essentially build a sustainable business around it? And to answer that question, we've just looked to other companies who've done this successfully before. We look at Mongo, which IPO'd recently. Elastic, which we hear is doing quite well. Even some startups that aren't quite at the IPO level, but doing quite well, like Databricks with Apache Spark and Confluent and Kafka. And essentially what we're learning is that sustainable business model is essentially an open core model, where the vast majority of your code base is open source, for the community. But there are some features that large enterprises need when they're deploying your database in production, typically around operational, and convenience, use cases. And those companies are actually more than willing to pay. They're actually more than willing to pay if you can solve those problems, because you're typically solving mission critical use cases. So one thing we're in the process of evaluating now is what does the enterprise version of Timescale look like? We already have some features that customers are using and paying for, but that's more on an ad hoc basis. And what I expect is in the next year or two, we'll have a more coherent story on what the enterprise model looks like. That being said, our main focus is the open source community. We think the only way this business survives is that if we really maintain and allow the open source product to flourish. So the last thing we want to do is severely hamper the open source product. But that said, I think it's in everyone's best interest if Timescale is self-sustaining. So we are thinking about how to build, that self-sustaining.
Talking about the future work that you have in store for Timescale, I'm wondering if there are any particular features or improvements that you have planned for upcoming releases.
Probably the biggest project we're working on in terms of improving the capabilities of Timescale is really focused on scale-out clustering for timescale primaries, so that you're not limited to a single node primary with multiple read-only replicas, but we can. Historically, people call this sharding. I sometimes stay away from that term because we, in some sense, even on a single node, we do this micro sharding where we could have sometimes tens of thousands of these little shards on a single node, which is how we get our performance. But it's that we could actually do inserts that in order to gain more capacity, you just keep rolling out new servers. And that's probably the largest engineering task we have over the next year. Thankfully, we have a very strong engineering team. Kind of the core of our team, a lot of us actually knew each other previously. A lot of them were my former PhDs and postdocs from Princeton and have worked on scalable consistency models and scalable transactional systems for many years. And so obviously kind of technically understand what the design is. And part of it is just the engineering effort to deliver, highly reliable product that one expects from, a core database.
Is there any particular help that people in the community can offer to help the Timescale database itself improve and grow in the future?
Definitely. I think, I think the database so far, I think we've had more growth than we expected, but we still fully recognize that there's a lot more room to grow, and we still feel like we're just getting started. We welcome and encourage any kind of community feedback and help, whether it's features, new features that we could add, if it's functionality that could be made smoother. Obviously, if there are any bugs or any issues that people have, we love to hear those so we can rapidly rectify them. But also, broadly, any feedback on how Timescale can solve someone's problem better. We want to hear that. If you look at Timescale today and you say, oh, hey, it's 80% there, but if it had this extra 20%, then we could totally use it. We want to hear that, and we will honestly take that to heart because we fully recognize that it's with our community's help that we together solve this problem and build the best time series database.
Are there any topics that you think we should cover before we start to close out the show that we didn't already discuss?
So in terms of the business model, often what companies ask, because look, if you're using a database or mission critical system, you want to make sure that database will be around and supported for years. So often what companies will ask us is how are you supported today as an open source business? And we're happy to say that we actually have some very strong investors who are backing us and supporting us. We just announced last week that we've raised $16 million from a few firms and a dozen angels, or more than a dozen angels. Those firms are NEA, New Enterprise Associates, and they're a firm that's been around for a long time, and they've invested in quite a few open source data related projects, including Databricks, Mongo, Elastic, MapD, and now us. Our other primary investor is Benchmark, and Benchmark obviously also has a lot of experience in the space. In particular, they've invested in Hortonworks and Confluent, the Kafka company, Docker as well, and the partners from there, it's Forrest Basket from NEA and Peter Fenton from Benchmark, and they're both I think probably two of the best, if not the best, investors in the industry. And we're so glad to have them. We also have Two Sigma Ventures backing us, which is the venture arm of a hedge fund here in New York. That's one of the leading quantitatively oriented hedge funds. And they're the only investor that we spoke to that had already built their own time series database, obviously because, for their own needs, they needed one. So they totally got, the need for a new time series database. And so it's been great to have them on board. And our angels include, the founders and CEOs of Hortonworks, of CockroachDB, of, Cloudflare, older, data companies that have exited that include Data Domain that EMC is a data storage company that EMC acquired for $2.4 billion. Nicira, which is a software-defined networking company that was acquired by VMware for over $1 billion. Some leading folks in the ad tech space, including the founders of Right Media and Moat here in New York. And so, we have a very strong set of people supporting us. And I think because of who we have on board and because of our momentum, I think we'll be well positioned for years to come to be able to grow this company and to hire the best talent.
Is there anything else that we should talk about?
Of course, if you have any questions after the fact, you can email us and we're happy to fill that in.
And so for anybody who wants to follow the work that you're up to or get in touch, I'll have you add your preferred contact information to the show notes. And as one final question to give the listeners one more thing to think about, I'll have you each answer from your perspective, what is the biggest gap in the tooling or technology that's available for data management today?
As far as data is concerned, we're in a very, I think, exciting time right now. We're at a time where, data is quickly becoming the most valuable resource for every business in every industry. And as a result, more and more businesses need more and more types of data infrastructure. But a side effect of all this, or I guess an effect of all this, is that data infrastructure challenges have gotten more and more specialized. So as a result, maybe in the past you had one database and that was it. Today you essentially have this kind of potpourri of data infrastructure, of components that are essentially plugged together, and essentially it's that glue that where things get challenging today. I think if you're connecting Timescale to Kafka, to Spark, to maybe a data warehouse, maybe to something else, it quickly you can see that your infrastructure can slowly get more and more unwieldy. I think that's a huge challenge today. We think the solution to that is actually is in leveraging SQL, which is maybe somewhat heretical in the data community. But we think even though SQL, it's old and people had essentially moved away from it in recent years to more NoSQL or bespoke options. I think SQL is really poised to make a comeback, in particular because if you're going to have this fragmentation of data infrastructure components, you need a glue that a common language that kind of links it all together. And we strongly believe that SQL is that glue, and that's obviously another reason why we're so bullish as a SQL-oriented time series database. I think that's it, actually. I don't think Mike has one.
Okay.
I had something along those lines, but I think that's a good way to end it, probably.
Fair enough. All right. Well, I really appreciate the both of you taking the time out of your day to talk to me and discuss the work that you're doing at Timescale. It's definitely a very interesting project and one that I've been following closely since I first heard about it a few months ago, and one that I'm hoping to make part of my infrastructure for a metrics pipeline that I'm planning to build out. So again, thank you for your time and the work that you're doing, and I hope you enjoy the rest of your day.
And thank you for having us.
Thanks for having us.